and now we feel like we're in a really good spot where we've felt out this problem space, and we want to help build some tools for other folks to be successful with operators. This is things like SDK tooling to help you build operators, so you're not doing all of the toil that you have to do to communicate with the Kubernetes API. You can bring your business logic and not have to worry about that. Of course, somebody has to worry about that. So we've got a team of contributors that are working on this SDK. And then we've got the entire lifecycle management side of things. This is, you've got a cluster and you want to run, maybe 100, 300 operators if we're successful with this whole thing on a cluster, and you need to manage the lifecycle of those, access control, all of those types of things. And so we want to have a lifecycle manager, one of the other parts of our framework, to help you solve these problems. And this is where I think the experience that CoreOS brings to the SIG and the Kubernetes community is really important, because I think we're the only ones that have thought through this problem. Other folks don't know that they're going to have these problems yet, and so we're very happy to help contribute that knowledge and save everybody some time. And so this is just part of the best practices that we want to develop in this SIG with the operator framework and then push to the greater community. And then there's a number of other things that are really exciting around how we can all support each other and have dependency management on operators. So if your application wants a Mongo database or a Postgres database, being able to say, lean on the existing work of a Postgres operator or whatever different types of queues and caching layers, I think will make a really vibrant ecosystem. And then we can all realize the goal of having these cloud-like services, the same user experience that you would get from an Amazon or an Azure, but on any Kubernetes cluster. And that's really the exciting part, is all of these are targeting Kubernetes APIs. And so you can run this on-prem, on VMware, on those cloud providers and have the exact same experience. And if you're one of the ISV partners that is looking to build an operator, for example, this now means that you can address the entire Kubernetes market without having to make Azure-specific product choices or Amazon-specific product choices, which is really important too. So, and kind of in the spirit of open source, all of these are being collaborated on with a number of folks, including everybody on this call. And so we're just really excited to grow that ecosystem. And I think I want to use this time to showcase what some of y'all are doing and the interesting challenges that you're hitting, as well as a lot of the successes that you're having, and then figure out where we take this framework from there to make it most successful, with the eye towards it being a true Kubernetes targeted thing. A lot of folks that kick this off, like I said, are from Red Hat and CoreOS, but we don't want it to remain that way. We want it to be a true community, and we think this is really important for bringing the future of Kubernetes. All the growth of the Kubernetes community is going to happen on top of the cluster. The foundation is really important, and it's already really strong. And so how can we make folks successful running applications on top of that? And if you are running a business, you're thinking about starting a startup, maybe around your operator, we want your company to be successful on top of this platform. I think that's all the thoughts I had. Thank you all for joining us today. I'm pretty excited about where we're going to go, and I hope you enjoy the hour.
All right, then. So in light of that, we have a number of people online here, and I think I've shared the gist. If you want to add yourself into the attendees and and we can keep up with who's doing what. For today, I've asked Sebastian Pahl to do a quick overview. So Sebastian, if you want to share your screen and your few slides and take it away, that would be great. And then we'll move on to Tom Bentley, and we'll have some Q&A in between, and we'll see how fluid this whole meeting is.
Perfect. Thank you very much, Diane. So let me share my screen. So just as an introduction, I'm Sebastian. I joined Red Hat not so long ago, and I'm basically leading the operator initiatives from the engineering side. And I'd like to present a little presentation that's going to overlap with a tiny bit what Rob just said, but mainly I want to show where to get started, where you can find everything. So let me share my screen. Right, this is not working, of course. Well, the application won't work. Here we go. Can you see my screen?
Yep.
All right. All right. Anybody who doesn't see something that I'm saying about, just say something and I'll try to slow down. All right, so let's get started. I'll keep this not in presentation mode because I want to jump to websites real quickly. So quick introduction, like what is an operator and what are we doing here? Rob touched a bit on this point. Our goal here is to build applications that have Kubernetes native APIs. And what that means is we want to take complex applications like, for example, Postgres or Kafka, which there's going to be a good talk about right after me. And we want to take all their logic and all the complex knowledge that is in each application and put it into a program. We want to be able to operate it automatically. We want to be able to leverage all the features of these applications that have to do with upgrades and other pieces. And we want to do it behind Kubernetes APIs. Why behind Kubernetes APIs? Because that way you have one way of managing all your applications. It's nice to build a single Docker container where you're going to have your application packaged in a way to run it anywhere. But we all know that applications get much more complex than that. And they require multiple containers. And then they require operational knowledge. What do I do with these containers? How do I deploy them? And that is specific to each and every single application. There's not one application out there, or at least there's a lot of different applications out there, and they all have their own quirks, their own operational knowledge. And it's really only the experts of these applications that know how to install them and operate them. And that's not even talking about when we get into the Kubernetes world. We chose the Kubernetes world because it allows us to create one standard way of doing that. And we want to give you tools and tool sets to help you build these applications. And I'm going to talk a bit more about this in the future. So how do you build an operator? What does it even mean to be an operator? So what we just defined a while ago and CoreOS kind of kicked off a few years ago was the idea that you could use Kubernetes CRDs, which are these custom resource definitions to which you can then post new resources on Kubernetes. And you can basically build an API that looks exactly like Kubernetes and that you can use with kube control, and not just kube control, all the tools that are able to talk Kubernetes. And you're able then to use that API to drive the entire application. And you want to encode all your best practices about that application, all the application domain specific knowledge into that operator. So upgrades, for example, when you're going to kick off upgrades of an application, you want everything to be in there to be able to do that smoothly. Same thing for failure recovery, scaling up, scaling down. And that's, I'm just scratching the surface here because we all know how complex applications can get. So the idea is if you build an operator, you can then do that in one single place, and then people can reuse that operator just like they've been able to reuse Docker containers. And that's quite powerful. Like getting it from having to learn everything about that application to being able to start it up in a second and worry about it anymore. And Rob mentioned a good point, which is it's the same feeling that you have when you're in the cloud. When you're in the cloud, and for example, use AWS, you go to you want a database, you provision an RDS, you basically do an API call, and you get an RDS database, and then you more or less forget about it. Like there's still a lot involved, but you at least have something that's running and that you can count on. And that's the feeling that we want to replicate on any Kubernetes platform, whether it's in the cloud, in your data center, and bring these services that take any open source application or closed source, but mainly open source applications, and bring that cloud native feeling and usability to your Kubernetes cluster. And you can build these operators with just like, in the end, it's a Kubernetes controller for those who are familiar with that. There's a loop that runs and you're able to react to events, and then you basically do what your application needs depending on the event that came. Or you can use tools that I'm going to talk about now, like the operator framework that will help you build those and help you not have to know about the intimate knowledge, need to have intimate knowledge about all these Kubernetes specific things that you might not want to know about. So what is the operator framework? The operator framework is, for now, it's 3 projects that kind of work hand in hand together. The first one would be the SDK. The SDK is, how do you build that? How can we abstract as much common code as possible between all these operators? Because if everybody's going to write an operator for their application, as much as there's domain-specific knowledge on these applications, there's also a lot of similar things. I like to use the example of TLS, right? Everybody needs to deploy TLS certificates, manage TLS certificates, and also be able to rotate TLS certificates. That is something where, while the rotation and the deployment of these TLS certificates is specific to every single app, the common codes to be able to generate those certs, to basically use a single one-liner to tell it, for example, on a Kubernetes deployment, I want this to now have a TLS cert in front of it, that can be abstracted away and used in a common manner across multiple applications. And so it's things like this, and also tools for upgrades, for metrics and others, that we want to encode into the operator SDK so that people have a very easy time to build operators. I hope everybody's following me until now. The next step, once you have an operator, is, well, an operator is good, but that's just one application you run once. And then what if you have multiple versions of these applications in your cluster? What if you want to upgrade them? What if you want to upgrade multiple at a time? That's where the lifecycle management comes in, and I'll talk about it a bit more later. But Rob mentioned it. It's a problem that people don't know they already have. It's basically the next step. And then metering. Another thing that building things with an operator can help is you can actually then take all the interesting metric and that's specifically interesting for people like ISVs or which is you can encode in your operator all the logic that you need to bring back the interesting metrics that you need to know. Is my application doing well? And also, how could I, for example, as a vendor, bill against my application? And how do I know if I'm inside of, let's say, AWS? How do I know how much this single database table or even row costs? Of course, that requires quite a bit of logic to write into the SDK, into the operator, but that logic can then be aggregated through the operator metering toolkit. So I'm going to go again on all of these through each of their websites. And there's a question. I'm just going to check if it's a question. We'll answer that later. All right. So mainly, that's the main goal of this presentation, is how do I get started? Where do I go? Where do I start? So the first part is obviously our operator framework org on GitHub. And there you have all the projects that are related to these things. One thing, you have lists of operators, and I want to also go into each project individually. So if you go, for example, to the SDK, you can see that that's the project. That's where you get started. And I want to talk a bit about how easy it is to basically get started. If you're familiar with something like, and not everybody likes it, but it's a good analogy, Ruby on Rails. When you do Ruby on Rails, you don't have to know the intricacies of HTTP. You don't need to know the intricacies of Postgres at first. And you can get started by basically using models, views, controllers. And you can also generate quite a bit of code, and you get a lot of utilities with that code. That's what the operator SDK tries to do, but for the Kubernetes world. So I'm showcasing like the getting started because it shows quite easily that you generate your application, and then you're able to build it. You put in your domain specific code, which was happened here, which is a much longer process than this shows, of course. And then once you're happy, you're able to build, push it just like any container, and then deploy it. And here it shows a deployment by hand because we don't have a lifecycle manager yet, but that's just an example. So I encourage you to come here. There's quite a bit of stuff to have a look at. This is just the getting started guide. We have quite a bit of documentation, the user guide, and more interestingly, if you're interested in knowing how you build your first operator, we've put in an example to show how you could build a vault operator with this SDK. And to go a bit more in like technical terms, because I'd like to to explain that here. This is the basic structure of an operator. It has multiple, like it has all the Go dependencies and everything, and then you would put your logic into one place, which is, for example, here. And you basically writes a handler. This one is a very simple handler that's now calling other pieces of the code, but the basics of an operator is really shown well here, which is you have a loop, you receive events from the Kubernetes API, and then you basically work on those events to do what you need for your application. So I encourage you to have a look at that part. Let me look for questions. Right.
There are a few.
Yeah, I just want to make sure that there are questions that might be used better to respond right now versus at the end.
Yeah.
No, I think we can keep these for QA. All right. The next step is basically the operator lifecycle manager. That's the next place I encourage you to have a look at. This repository is quite simple to use. It also has the same getting started guide as everything. You don't need to, it works and it will eventually be included in OpenShift, but you can install this on every single Kubernetes cluster. And that is an important distinction, because if imagine you have to use different, variety of Kubernetes styles, it doesn't matter. As long as it's a Kubernetes compatible cluster, you can install that lifecycle manager. And what you get out of this lifecycle manager is basically a repository of applications where you can then decide to deploy these applications in a multi-tenant fashion. That's one of these goals. The lifecycle manager is aware of Kubernetes namespaces. It's able to tell it, and it also does one other important thing. It manages the CRDs so that users don't have to install them themselves. They don't have the permissions to do that. They only have the permission to then use the lifecycle manager, deploy and upgrade operators. So it's something that is quite useful, and also allows to abstract a lot of code that people usually encode in their own operators. Like that's what we've seen in the past. People tend to build an operator or what we call an operator and put in a lot of this logic that can here again be abstracted in one project in one way of doing things. And that's it. And then the metering part. The metering part is a bit more complex to install, but it is also installable on every single Kubernetes cluster, and is basically our goal, and it's not completely integrated yet, but our goal is to make it so that once you have metering and OLM installed, if you deploy any framework any operator that has been built with the operator SDK, you will immediately be able to see those metrics and those and be able to build reports about usage in your cluster from all these applications. The last part I'd like to highlight is we've made a list of operators. Not everything here uses the operator SDK, but if you've built an operator, I would encourage you to contribute it here, to highlight it, and basically this repository is probably going to get curated more and more. We're going to show off what's built with the operator SDK, what's not, what can be used, but right now it's basically a list of many things. But you can see that already a lot of people have liked the operator concept and started building what's called an operator for their specific platform. I don't want to vouch for the quality of each of these, since they are not like going through any certification process whatsoever. And that's where the operator framework also comes in. Our goal is not just to help you build these operators, but eventually our goal is to help you test these operators, make sure that they work, that they behave well in a lot of environments. So we want to build through the SDK, a common way to test them and to certify them on the platform like OpenShift. That is what's going to transform a list like this, which you've all seen in the past for various applications, containers, and basically know, yes, that's a list that's I still have to do my own research, but with once we're a bit further down the road with our testing kits, you'll be able to know, oh, this actually has been tested out automatically on the kind of Kubernetes cluster that I'm running. and we won't have to use lists like this, and we'll be able to go in a much more automated fashion, and you'll be able to trust it much more than a random Docker image, for example. So that's a quick intro through all of that. And then the last things I would say, take a look at our Getting Started guide. It's much more in depth than just the one on the operator SDK that I showed off here. It is an end-to-end test with operator SDK and the lifecycle manager. We'll throw in the metering in it eventually, but this will enable to do everything that I said, try out everything what I said in a single Kubernetes cluster quite easily. Like just follow this and everything will become much clearer. The last things I would like to add are we created a channel to talk all things operator on the Kubernetes Slack, and we also have a Google group. These links will be shared by Diane after for everybody who wants to join. So that's it. That is the main thing that I wanted to do and what I wanted to highlight. Quick intro and showing you what each and every one of these components are.
All right. Well, thanks, Sebastian. I think that helped kick it off and set the groundwork for, and especially the concepts and the links. And I will add all of that into the gist and into the mailing list as well. There are a couple of questions, and some of them have been answered in the Q&A and chat. But I think if we go back to Alexander Lazik's question, and I can unmute people, it's two as well. So if Alexander wants to follow up on that, find you.
Sure.
And you have muted yourself, Alexander. So
I'm not. Yeah.
Can you hear me?
Yes, now I can hear you. So why don't you ask that question out loud, and we can have a conversation about that as well. We'll work our way through the Q&A.
The question is, you have always in combination with CRDs, but the operator themselves can run on Kubernetes kinds like ingress or routes. So do I always need the CRD, or can just run the operator and listen on the routes or ingresses without any CRD?
So I'll take that one. The goal of our framework is to go through CRDs. Like, of course, you can write Kubernetes. Like, if we forget about the framework for a second, you can write a Kubernetes controllers that does all this, right? That listens just to specific things. And also, the operator framework itself is also capable with the SDK of listening to specific objects. But what we're trying to do here is kind of an opinionated pattern where we drive things through CRDs because it allows us to, like, you need to put that API somewhere. And if all your controller basically is doing is like doing some ingress work, or let's say watching a couple of stateful sets and doesn't need to be basically influenced through a CRD, then it's not necessarily you don't necessarily need to use something like the SDK, but you can still call it kind of an operator, right?
Cool.
You want to add something, Rob?
Yeah, I was just going to say that in like your case, if you're orchestrating like an external DNS provider, the CRDs still might have a place for you to hold configuration. So say like the external Amazon zone that you want to write these DNS records to, and then you want to listen on the routes or and then, hook up the services or whatever. So I think there's probably still a place for a CRD in there because you need that configuration for what this thing is going to do, even if you're listening on other resources.
Yeah, we have talked in the Slack channel. Perfect, thank you. This helps me a lot.
There was also a related question right on this in the chat, which was about whether or not the SDK would make it possible to run reconciles against built-in resources other than CRDs. Maybe you could add on to that, Sebastian.
Sure. I mean, you can. The goal of the SDK itself is to reconcile everything from the CRD top down. That doesn't mean that you can't do it. It's just a pattern that we have adopted that we kind of prefer for the most common use case.
So like, for example, you could listen for pod events in your namespace if your operator cared when pod came and went, for example, even if it's still driven top down, right?
Yeah, actually, there's even, like, I could share an example of an operator that actually uses the SDK and does that. It was one of our partners during launch at Summit.
That might be an interesting thing to add the link into.
I will. Just need to find it. Okay, next questions.
While you're finding that, I can
right.
answer there was a question about metrics example. And so this is really interesting for when you're modeling a really complex application. Say that you're an IT administrator and you're running, you've got 30 different engineering teams that are using your shared infrastructure, the Kubernetes cluster. And they all want to run databases for whatever reason. So you've got, you've tested out this Postgres operator, but you're running, say 30 copies of it, and every team is running databases with the operator. And then say you have a node failure or you have a networking blip or one of your AZs goes out. If that Postgres operator is instrumented to start emitting metrics about when it's doing failover or when its shards or whatever kind of underlying storage is not available, you can start to get a sense of like how these things impact the actual applications that folks are running without having to go around to every team and say, hey, did this impact you? Did you have downtime? Whatever. And you're getting like the actual application level metrics from Postgres itself or from this operator. So that it's really like not just generic white box like, oh, the network request went down or like, oh, it's now using less RAM or whatever, which is useful information too. It's that you're getting a very specific thing. So another example, say you were running like a very large cluster or Ceph cluster, that if you have to do heals on some of that underlying stuff as things are getting replicated around, knowing how many of those happen per hour or per week or whatever, and correlating that to cluster events can be really, really useful for you to help either make your operator more efficient. Why is this thing healing so much? Oh, I have a bug in my logic, or oh, it's just that the infrastructure is a little bit flaky, that type of thing. So you have all that insight if you have this metrics across the namespaces that an operator is running, and that aggregation is what's really useful.
May I have a follow-up question to this?
Yes. So David, why don't you follow up?
Thank you. Hello. I wondered if I would be able to make this metric system get domain knowledge of my operator. So let's say I have a program and there I want to charge by users. So would I be able to plug easily the domain knowledge of my application into this operator matrix?
Yes, 100%. Those types of metered billing type use cases are perfect for this framework. And that's one of the exciting things that, there's like a set of operational things, but then also a set of business things that you can get unlocked by using this. And so, yeah, what you would do is in the SDK, we're going to build some functionality where you can say, I want to emit this metric that I'm already tracking, and then it'll get scraped by the metering system and then aggregated.
And if you look at the current pull requests or open and closed from the operator SDK, you'll see that it's actually being worked on right now to have metrics in either by default and also to be able to expose your own metrics.
I'd also like to call out that with at least metering, the actual getting that data is only the one half. And so like the metering component offers APIs, and long term, we're going to probably build in default exporters that can basically, on top of the existing reporting functionalities that you already get, you can query the results out of these APIs. And so then the next piece would be for us to make it easy for you to get that kind of data out. For example, you said you want to know how many users are being used in your app, or how many there are. Once we have that, the next question becomes, how do you get it back? And so we're actually like really interested in like those types of use cases. If you have like, we want this data, but we also want to get it back home for us to use. That's one of the less the things that we're looking for more feedback on, since it's kind of up in the air still on how we want to achieve that, what kind of defaults we should be doing. So we'd love to hear more about that.
There's another question in here that Yolanda is asking, which leads to another topic that I think is near and dear to all of our hearts, is interested in the lines between when to continue to leverage Helm for installing applications versus using an operator and how they complement each other. And I wonder if we could address that here, or if that's something we need another hour to do, or whatever.
No, I don't think we need another hour. I had it highlighted here to give a quick answer. So one thing to know is that's actually somewhere where we can help quite a bit. So what we have is actually a Helm operator that is there, then you can use kind of very easily once you have the Lifecycle Manager installed, and that kind of gives your app quite a bit of ways of using Helm charts with operators, and you're able to use then Helm without tiller. You're able to use Helm without having too many privileges, which is something that is quite useful. And about Helm versus operators, I'll let Rom for a bit, but like they complement each other, right? Like Helm apps are simpler apps that don't need as much logic as an operator would have. That's how I would say it quickly.
Yeah, and if you think about it this way, Helm is really good for running these stateless applications, but it's kicked off with like the Helm CLI, or it's like a human is in the loop there. And so one of the exciting things about the operator is you're taking that human out of the loop, and then you're making it Kubernetes native. So you're not having to write against a Helm API. You're just using a CRD. And the way our Helm operator kit, I linked it in the chat, works is you model, you don't have to model a CRD. A CRD is modeled for you that basically has your values that you would pass into a Helm chart as the configuration in the CRD. And then when you instantiate that, you have the image that the operator runs in actually has your chart baked into it. This allows you to version it with container tags, which is really nice. So you've got this immutable artifact. You pass in the values, and then out pop, whatever your chart is making. And so that's really nice because you're not having to run tiller, which has its own security issues. They're actually moving away from that in Helm v3. And then you're also now can apply Kubernetes RBAC to those objects. So within a namespace, if you want people to be able to create whatever your CRD is that this Helm chart makes or is listening for, you can say who can do whatever to those. And so you get all those, you get the Kubernetes audit log and all that type of stuff already built in. And then if you're using a UI that models CRDs, then you get a UI for free. So there's a lot of reasons to use Helm with an operator, especially if you've already invested in Helm charts. And then over time, if you want to add more stateful kind of stuff to your application, then what you can do is move it over to, I'll say like a real true operator, a Go code operator, and do the same thing, model those things, and then start building in your stateful logic. And so that's where we think the Helm operator kit is really nice, is it gets you started with an operator, and then you can kind of decide how much further you need to take it.
No, I can tell you confidently this works because I don't use the actual Helm operator kit we developed on the metering project, but I use a precursor to that is a Helm operator, and 90% of the components in metering are deployed using a Helm operator stack, and then that operator is actually what deploys the bespoke Go operator that does all the specific metering stuff as well. So it makes sense, even if you are writing a custom operator, what if you need to configure that operator itself, right? And so this is where like basic templating is really, really nice. And you don't want to write a bunch of Go code to just do some templating of some YAML basically, right? So there's a good place to be able to use both systems. And just a shout out too, people are working on an Ansible operator as well, like a similar kind of bridge for people who have playbooks to be able to interact with Kubernetes through a playbook with the Kubernetes modules in Ansible. And then the CRR is kind of the edge trigger for your Ansible playbook and its inputs. So that's also coming up in the next couple of months. Thanks.
Hey guys, in the interest of time, because I've asked Tom Bentley to give a little hot topic too on Strimzi, we're going to pause the Q&A, save all those questions, and because there's a couple of them that are good ones too, more logistically inclined. But if Tom was going to give us a little talk on Strimzi, which might elucidate some of these topics as well, if that's okay, shall we let Tom share his screen and kick off his talk as well? And Sebastian, if you can put a link into your slides, that would be great.
Yes, I will share them.
Take it away, Tom.
Okay, hi folks. Hopefully you can see my screen.
Yep.
start presentation mode. There we go. Okay, so I'm going to be talking a little bit about Strimzi, which is about running Apache Kafka on Kubernetes and OpenShift. So if anyone doesn't know what Apache Kafka is, it's basically a highly scalable messaging system. It's come out of LinkedIn quite a few years ago now, and it's obviously being a messaging system. It is quite stateful, and for that reason, it's something which is quite well suited to using operators. So the Strimzi project is about making that as simple as possible so that you can just use Kafka in Kubernetes and OpenShift without having to necessarily know all the operational details. So obviously the operators sort of embed some of that logic. So we've actually got two operators in Strimzi at the moment. We've got the first one is called the cluster operator. And what that does, it takes a custom resource which represents the Kafka cluster, and it will deploy a corresponding Kafka cluster and a Zookeeper cluster, because Apache Kafka relies on having a Zookeeper cluster available to it. So obviously this cluster operator is responsible for managing the scaling and rolling updates and everything to do with the Kafka cluster running inside Kubernetes. So the managed resources that the sort of operator is responsible for are a stateful set each for Zookeeper and Kafka. And then we've got some services in order for the clusters, the Zookeeper cluster and the Kafka cluster, to communicate amongst themselves, and also to provide client access to the Kafka cluster and for Kafka to access Zookeeper. We need persistent volume claims because, as I said, these things are stateful. So in particular for Zookeeper, it's important that if a pod gets restarted, it has access to the same data that it had before, because it won't be able to recover that from the rest of the Zookeeper nodes in the Zookeeper cluster. For Kafka, it's not quite that bad, because Kafka's built-in replication is able to recover, but it can take quite a long time. So it's worthwhile using a persistent volume claim in order to minimize the amount of time it spends fetching information from the rest of the cluster.
Tom, I'm just going to interrupt you.
There's also.
Are
Sure.
you? We're seeing your notes, but not your slides. If you're intending to share slides.
I shared the wrong screen.
I think so. Yeah, that's okay.
Okay, can you see the slides now?
Yeah, absolutely. Thanks for that. Sorry about that.
Okay, super, mate. That's all right. Okay, so I'll just, well, I suspect people have probably been following on, so I'll just carry on. So the other operator we've got is what we call the topic operator. So once you've got this Kafka cluster running inside Kubernetes, the next thing you want to obviously do as a user is you want to start using it, and you will want to be able to deploy your Kafka applications inside Kubernetes in order to use it. And it's kind of nice if, as part of that same deployment, you can have a custom resource representing a topic within Kafka, so that you can deploy your topic and configure it at the same time as you're deploying the rest of your application, without having to have sort of extra manual steps or extra scripting in order to set up the topics that your application needs. So that's the sort of the rationale behind the cluster operator. And this is all sort of well and good, but there's a bit of a problem, which I'll get onto in a minute. Hang on, I'll just talk about this slide first. So this is what our custom resource looks like. We started off using config maps actually to represent the topics, sort of identifying them with a label, so that we knew which config maps represented Kafka topics. And this is now the sort of the custom resource direction which we're now going in, which I've been working on this last week. So as you can see, topic is sort of relatively simple thing. It's got built-in partitioning, so we have to say the number of partitions in our topic, and we also get to say the number of replicas in our topic. And there's a bunch of different configuration options. So there's about a dozen or so different topic configs that you can set there. So that's what the topics custom resource looks like. But the problem that we've got is that in Kafka, there's an API for creating topics, so applications can create topics themselves. And also, there's, depending on how the broker is configured, if you try and consume from or produce to a topic that doesn't exist, it will get created automatically for you, which means the scope for things to get out of sync, we can end up creating topics in Kafka, which then there is no corresponding resource for in Kubernetes. So that's sort of something that sort of gets in the way of this sort of otherwise quite nice concept of being able to use custom resource Kafka. So we wanted to make the sort of the synchronization work properly, which meant that we would have to create topics when topics were created in Kafka, we'd have to create them in Kubernetes or OpenShift. So we ended up having to contemplate having a topic operator that would synchronize the topic information in both directions, so it would be bidirectional, in other words. But if it's going to be bidirectional, we have to consider what's going to happen if the two ends change the same topic at the same time. So on the left here, we've got a topic as it might exist as a custom resource inside Kubernetes. And someone might change something there, and at the same time, something might get changed on the Kafka side, and we don't want the state to get all out of kilter and end up with a mess where the resource in Kubernetes doesn't accurately reflect the topic in Kafka. So you might think that the chances of that are pretty small, but the window is probably bigger than you at first realize, because we've got to consider that the topic operator might not always be running. If it crashes and restarts, then the window will be as big as the time that it's down. And if it gets undeployed and then later redeployed, then again, the window could be quite a lot bigger. So to do it properly, we've got to deal with this inconvenient fact that both ends can change at the same time. But if you think about it, if the operator starts up and it sees the state on the left and the state on the right here, it can't tell what's changed. It doesn't see the things which I've highlighted in bold. It just sees, some set of properties and some other set of properties, and it can't tell which end has changed since it last tried to reconcile. So to solve that, we use a three-way diff. Basically, we have our own copy of the topic state, which we treat as the source of truth. And whenever we reconcile the custom resource, we compare it with that private copy, that private state. And likewise, when we're looking at the topic in Kafka, we compare it with our private state. And from that, we can figure out sort of how that end has changed, so how the Kubernetes resource has changed or the Kafka topic. And then we can check, first of all, that they've not changed incompatibly in the same place. So if the number of partitions, for instance, has been increased to a different number on each side, then obviously that's an incompatible change. And in order to deal with that, we have to apply some sort of policy over which side should be the winner. But if those two differences are disjoint, so they have an empty intersection, then we can construct the union of those two differences and apply that to both sides, and that will reconcile the changes which happened at both sides. So in this case, the union looks like this. The number of partitions is changed to 18, and this config property is changed to that. And in that way, both sides end up having the same state. So obviously, this is not the normal way that you would write an operator. An operator is normally sort of, first thing to say really is that you only want to make your operator bidirectional if you absolutely have to, because it does increase the logic rather a lot. And obviously, the simpler your operator is, the more likely it is to actually work properly. Another consequence of this is it makes the operator stateful, whereas a normal unidirectional operator is pretty much stateless. It's just consuming the resource on the Kubernetes side and then trying to make other resources match that. So with it being stateful, we have to worry about the availability of that persistent state. So for us, it made sense to use Zookeeper because it's required by Apache Kafka anyway. And therefore, if Zookeeper is not available, we wouldn't be able to reconcile the topic. But if you were having to contemplate something like this yourself, then you would have to have some highly available persistent store available to you to be able to do that properly. And finally, this middle bullet point here is you always want to make sure that you update your private store of state last, so that if your operator happened to crash before that gets updated, but you've updated one or the other side, then when your operator restarts, it would correctly synchronize the state again. So that's the end of the slides. I'm hoping to do a demo as well now. So I've already got the cluster operator is up and running. So you can see we've got a bunch of different pods going on there. So we've got the cluster operator itself at the bottom here, and we've got a cluster of 3 Zookeeper nodes and 3 Kafka nodes. And I've also got so in the slides, I've shown you the custom resource version of the topic that I've been working on this week. Unfortunately, I was hoping to get that, although I was hoping to get that working for this demo, I've not quite been able to get it working in time. So I'm going to be showing you a version that's based using config maps to represent the topic. So you can see here we've got the same sort of data that we had in the slides here. So we've got some number of partitions and some number of replicas and some config. And likewise, if I've got it back in my history, I can that is running in the Kafka cluster. We've got that same topic, and if you've got the 5 and the number of bytes in the segment ends in a 7 here, and they're different. It ends with 30 and 02. So what I've done is I've prepared it already so that both ends are slightly different, and the topic operator, as we saw when I got the pods, isn't running yet. So I'll now start the topic operator, and hopefully we'll see that both sides match up. So just so that you know, so it was this one which changed on the Kafka side, it was the segment bytes. And on the Kubernetes side, it was the retention milliseconds, which I can now say OC edit my cluster. You'll see this is the custom resource that we're using to represent the Kafka cluster itself. At the moment, this doesn't include set that to use the empty object, which means it will use the defaults which are right for what we're trying to do here. So this, when I save this, it will create the topic operator inside that cluster. See it? Yeah. So it's started up there, but it's not yet ready. Wait for that to become ready. Now, hopefully, I can get the one side which is showing the 5 and get the other end, the YAML, which is showing ending in 30. So it's reconciled both ends when it started up. So I think that's pretty much all I've got to show you. Has anyone got any questions?
I have a question. This is Diane Fatima. I was just wondering how you deal with race conditions if topics are being created and deleted. So how do you create a critical region? I'm just curious about the in Kubernetes, how do you avoid that race condition?
So that's not something which the operator actually deals with right now. So I must admit I've not put a lot of thought into that. I mean, obviously, you're unlikely to have the situation that you're going to have the same topic created and deleted indefinitely. Will eventually either end in one state or the other, and the operator should deal with that. But in the meantime, I imagine it would keep going. But I must admit that's not something I've thought through fully yet.
Okay, just curious. Wanted to know how that sort of thing is handled in Kubernetes, or how, you know, the mechanism at this level. Since you're not down in the operating system, you're up higher than that. So.
Yeah, I mean, certainly in the cluster operator, we use a locking strategy so that we only are processing the cluster sort of, you know, with one thread at any one time, basically. So although you can have multiple clusters all sort of being reconciled simultaneously, there's only one which is being operated on. Sorry, although you can have multiple being reconciled simultaneously, there's only one thread which is operating on any particular cluster. Yeah.
Okay. All right. Thanks.
And then if you sort of synchronously wait for the resource at the other end to reconcile, then yeah, that would stop you from sort of trying to reconcile at the same time that you were sort of already reconciling.
Yeah, I was just recognizing that this three-way diff could be a tricky situation in some cases.
Are there any other questions for Tom? Everybody just digesting that one. Really just digesting.
I was going to pose a question to the group just around, does anybody else have a need in an operator or can think of a situation where you want to have this kind of bidirectional traffic moving where, you know, you're going to use some like the Kubernetes APIs to create a CRD that might drive something in the operator, but then also have to consume things that would create resources of that same type from a different API?
Yeah, I have a use case like that. We're going to be building an operator to work against Keycloak, which is an authentication server. We want to allow the developers to define which realms and users and clients they want to consume in their application, and have the operator set those up and drop them into secrets for that user to consume. So they could potentially log into that Keycloak and change something about one of those things that then would mean that the secret would be out of sync, for instance. So that's probably another situation where you could have this sort of two-way sync. We are kind of going a simpler route where we're saying that Kubernetes is the system of record if you're going to use the operator, and basically always sync from there. So if they make the change, it'll get removed and replaced, but obviously documented.
Yeah. Yeah, if you are in the position to say that you know the Kubernetes is the way and the only way to do it, then that's definitely the way to go, because it's much easier to have a policy like that. We couldn't because of Kafka Streams, for instance, the way it creates topics dynamically. Just meant that we can't sort of turn around to people and say, oh, well, you shouldn't be using Kafka Streams, because that's, you know, one of the main sort of selling points of Kafka. So yeah, we felt that we couldn't really take that approach.
Anything
I guess
else?
the previous question of just when you can use Kubernetes as your data source of truth, then you get all the atomic operations that you get from the Kubernetes API, which really, you know, are the etcd primitives that are being pulled through. So you can do like those compare and swaps and, like, you know, only have one person operating on an object at a time, which is pretty nice.
I had a quick question. I think I just heard this. So the topic or stream resources do provide all the information to access it. Is that correct? Like a secret, credentials, etc.?
I'm sorry, I don't quite understand what you're asking, Chance.
Does the topic or stream resource provide all of the necessary information for connecting to said topic or stream, or would that be also in the maybe the I guess, yeah. Does it?
So
is there like other information that would also be needed to be retrieved, basically?
Are you sort of asking, is this sort of more about like having a status section in the CRD, for instance, so that you can usually consume the resource from something which depends on reading it?
Right, like this is based on the topic in the SDK mailing list that we had, which is if your resource gives me if it exposes a secret for connecting to it, for example, and has a URL or whatever it needs to talk to it, maybe it's just the name of the service and the port, then what would be really exciting for me is being able to actually just prototype using your Kafka operator with my metering operator. And so I just wanted to know like what kind of support there would be for that, if any.
Yeah, it's nothing that's on the immediate roadmap, but we do want to add support for sub-resources in our CRD eventually. So you'll be able to scale the Kafka cluster using the kubectl command to scale it and stuff like that. And likewise have status information so that you can easily consume the endpoint from other things. I think that's what you're asking about.
Yeah, basically, because what I would like to see at the long term is where if I enable the flag auto connect to Kafka streams, like my operator would be able to discover these streams and create database tables that and fill the data in those tables with the content of the streams. And I actually have very specific use cases in mind for this. Like, man, if that FluentD operator ever ends up sending to Kafka, I could start analyzing these logs. And that would be, I think, an extremely interesting use case for certain things. So it's just exciting to see where these could kind of interop.
Yeah, no, we definitely want to get to, I mean, that's sort of one of the benefits of having the topic resource is it sort of makes it all sort of much more Kubernetes native. And then, you know, obviously sort of other software such as your own is able to consume these resources as well and discover them. So yeah, that's definitely one of the benefits of this approach.
Are there any other questions on this topic or anything people want to add? No, there are a couple other questions in the Q&A. I know we're over the hour and a few people are dropping off, but I'm quite happy to stay on and continue to record and do some of this Q&A since it is the kickoff. I know there's a lot of things that are top of mind. The most recent question was Peter Wilsinski asking about an SDK for Java as well.
Yeah, I can take this one. As Seb said in the chat, we're really starting with Go because it's currently the easiest to get up and going because of all the client generation and stuff that Kubernetes has built into it. But of course, Java is probably the next language that would make sense to go into, just because of it's widely adopted in a lot of enterprises. A lot of software is already using it. And so especially when you're trying to talk to, you know, other APIs that are have a Java interface, for example, is really useful. But right now, just due to, you know, getting started and iterating on the project and all the projects inside of the framework that are all Go based, we're gonna stick with Go, but definitely open to other languages over time. But no commitment or timeline for doing that.
I'll just chip in and just say that our operators are written in Java, and yeah, although sort of SDK type support would be nice, it's not difficult to get it working, but there is you obviously the SDK sort of abstracts away a lot of the common stuff, and it would have been nice if we'd have had sort of something that could likewise do that. You know, sort of abstracting away the TLS and whatever would have been great. We're having to do all that by hand. So although the APIs are there, there's a lot of legwork to do at the moment, writing stuff in Java.
Yeah, absolutely. And we're kind of a bit of in conflict between, on one side, we have Go, that's like the lingua franca of Kubernetes and this world, and then Java, the lingua franca of the enterprise. And we're trying to marry that in, like, eventually we'll get there, right? Like, this is something that we want to do. We're very aware of it. It's just, this is how we get started.
Peter, I'm curious if you want to use Java because it's just like your skill set and what you're most productive in, or if you have a specific dependency on another Java application, and that's what's driving that. You can either share in chat or go on voice if you'd like.
Yeah, so most of the team uses Java and they are most familiar with it. And also around Apache communities, Java is the the most used. So that's why I asked.
Into Java, if you're going to write anything that talks to Zookeeper, there's pretty much zero chance you should use anything other than Java for reasons that most Zookeeper clients have bugs that break everything usually when it's not written in Java. So that's like where I've seen most of that ask come from myself.
There was a question earlier. I apologize. I dropped out for 2 seconds and lost all the chat. So Rob, if you can cut and paste it and throw it into the notes section of the gist, I think you can add a comment to the gist and then I can put it in. But the earlier question was something around the about creating a community hub for operators, and that's something that's we bandied about a little bit before, but maybe something we can talk about on the mailing list a little bit, and what Rob or Sebastian, maybe you have some thoughts about that, where we go beyond just a repo called awesome.
I don't know if we have a specific plan for this, but would love the input. I'm not really familiar with the way that the Jenkins model works. So if somebody wants to give a 30-second overview of that, I'd really love to hear it.
Yes. Sorry, yes. I was the one who asked that question. So basically, with Jenkins work like this, you can kind of you create your plugin in your own repository in GitHub. Once it's ready, you basically open a Jira ticketing to the Jenkins with the Jenkins team. They will review your code and ask you to fix the stuff where they see fit. Once that stuff is done and ready, then they fork your repository into their organization, which is Jenkins CI. And by doing that, you basically can install your plugin from the Jenkins servers instead of manually uploading your Jenkins file into your Jenkins instance and so on. That also, so that's one of the things that you can install that stuff from the Jenkins Update Center. The other advantage that by doing that is that also you do that plugin belongs to the Jenkins community. So for any reason that you kind of can't maintain it anymore or you're not interested, maybe you change your job or something like that, then someone can send an email to the main list saying that they want to become the owner or a contributor. And if no one objects that, then you basically move the owner of the repository to this new person and so on. So that's basically how the Jenkins workflow works.
Gotcha. And this is kind of my takeaway from that is twofold. One is there is a way to just share these things so that other people can use them. And then it's more of like a source of truth, like is Git, and has like a kind of that operational model such that information is not lost if somebody like deleted their account or something like that. So that's interesting.
Also get like a free like Jira project and other things like that as well usually. So like it's like if you've ever seen the Apache Software Foundation projects, it's like being adopted into that, where you get a bunch of resources and CI and everything as part of it.
Yeah, that's true. If there's an issue with the plugin, you can just open a Jira into the Jenkins Jira instance. So you don't need to kind of host all, so they basically call it host your plugin into the Jenkins infrastructure. You get all that stuff for free.
Yeah, that sounds familiar just in concept to a lot of other things out there of successful communities. So I'm glad you brought that up. And then kind of parallels with some of the thoughts that we're thinking about that Seb mentioned around like testing, for example. We'd love to have a way to test everybody's operators. So if we can instrument the SDK such that, you can test the failover and scaling or whatever mechanisms that your operator is providing. We can test those against different versions of Kubernetes. And so if there's any breaking API changes, people know what operators work how, and like testing them against big clusters and small clusters and forcibly kill off nodes and see how they perform, that type of thing would be a really great input into this as well.
Actually, I think that was my main motivation behind that question, because as you mentioned before, that you don't vouch for chosen operators; they're just there just as a showcase for what you can do with that. That having kind of like an official organization or something like that for operators, that would imply that one of the requirements, like shows are tested, they do have a continuous integration, continuous deployment test. They could be hosting some a container repository as well. So that's something that the Jenkins community also you also get that for free from Jenkins as well. So one of the requirements is to add a Jenkins file where you just call one Groovy function. So you also get those integration tests for free as well by moving your code into their infrastructure.
Gotcha. Yeah, that sounds awesome. Yeah, we'll definitely take that into consideration for sure.
So we're about 10 minutes after 10. I did manage to figure out how to capture all the chat stuff, so don't worry about it, Rob. I've figured it out. And I had a couple of things that I just wanted to put out there, and I'll put it out in the mailing list as well. KubeCon North America is coming up in Seattle, and I'm hosting an OpenShift Commons gathering day there, and I was just going to put it out there that maybe that would be a good time to have a face-to-face operators type meeting. So if you're interested in that or helping to organize that, reach out to me, and we'll figure out, how much time we need and space, and I'll work with Rob and everybody else to see if we can make that happen. The dates for KubeCon are the 11th, 12th, and 13th of December, and I usually get a room the day before for a big OpenShift thing, and I could probably get a smaller room and have some sort of an operator framework working group meeting, or even a hackathon, hands-on workshopy thing, so we can figure out what the context of that would look like. And if you're interested in doing that, let me know, so we can figure out space issues and things like that. Next meeting would be for this, I think is going to be the 17th of August, is what I have, again at 9 a.m. Pacific, if that time and date works for everybody. I just like to keep repeating because I'm kind of like that. If you think we need one sooner than that, let me know on the mailing list. And Sean, I'm putting you down as one of the possible speakers, an Ansible operator next time. And if other people have things that they'd like to talk about or questions, send via the mailing list or to me, and I will add them in, and we'll do it time permitting. I think I don't know how people feel about the feedback on this, and we can do that on the mailing list as well. But having two topics, one that's sort of an update on something new or something different in the operator framework or metering or something like that, and then one operator talk. Seems to work good to get content out there and shared, and I would love it to be different people doing different operators, because it's bi-directional conversation. Tom is great, and it's obviously interesting to everybody. And again, thank you for sharing and taking the time today. Rob, is there anything else you want to add to this?
Just thank you all for joining. This is a great first meeting, and we're looking forward to interacting with you on Slack and the mailing list, and we'll see you next time.
Okay. I will try and get this updated and uploaded into YouTube this afternoon. And what I'll do is I'll take the two topics that we talked about and edit them into shorter videos too, so people don't have to watch the entire talking bits here, so that there'll be some content there. So you can look for it on RH OpenShift on the YouTube channel, and I will post all of that on the mailing list as well. And I will try and figure out something better than GIST, so that we can collaborate on the notes and people can update the notes as well live. That looks like the suggestion is hack MD IO, so I'll take a look at that and try and use that one too. Anything else? Anyone wants to add? Sebastian, Chance?
No, thank you very much, everyone.
All right.